The Beer-Lambert law relates absorbance and concentration. You will often be tasked with making a series of dilutions of known concentrations and recording the absorbances of these samples. When making dilutions of a colored solution, it is optimal to have the absorbance values in the range of 0 to 1. Deviation from the linear relationship between absorbance and concentration can occur at higher concentrations, as illustrated here. The Beer-Lambert law is typically expressed as follows: A equals epsilon times B times C, where A equals absorbance, epsilon equals the molar absorptivity coefficient, B equals the path length of light, C equals concentration. You can think of the relationship between absorbance and concentration the same way you would between y and x in the context of a linear equation. In this context, the y-axis equals absorbance, the x-axis equals concentration, and the slope equals epsilon times b. Understanding the units is important. B is typically 1.00 centimeters, concentration is typically moles per liter. Absorbance has no units, so in the units of epsilon, the molar absorptivity coefficient, when multiplied by centimeters and moles per liter, must cancel out. In most cases, if B is in centimeters, concentration is in moles per liters, then the units of epsilon are liters per mole per centimeter. Theoretically, the absorbance of your blank solution should be 0, but practically, your data may not be perfectly linear, resulting in an intercept which is not 0. If a series of dilutions are made from a stock solution of known concentration, a standard curve can be made. This data relates absorbance to concentration. Shown here is an example containing 5 data points: an undiluted sample of the stock solution, 3 diluted samples, and a blank. Plotting absorbance versus concentration will give you a standard curve. A linear relationship between absorbance and concentration can be observed, so if you were given a sample of unknown concentration, which was made from the stock solution, if it had an absorbance within the range of your standard curve, you could calculate the concentration of the unknown sample. Let's say you were given an unknown sample of the colored dye and it had an absorbance of 0.356. You would then use your standard curve equation to solve for the concentration.